Find the magnitude and the direction angle of the vector v with components -4 and -4 root 3. Let's start off by working on the magnitude first. The magnitude is easy. The magnitude of any vector, its length, is just the square root of the sum of its two components, so v1 squared plus v2 squared. In this case, that would be the square root of -4 squared plus -4 root 3 squared. So if we square those, -4 squared is 16. -4 root 3 squared, let's see, 4 times 4 would be 16, and root 3 times root 3 would be 3. And so if we clean this up, that would be 16 plus 48, or the square root of 64, for a grand total of 8. And so that's the magnitude of the vector. And that answers the first part of the question. Now let's focus on the second part, the direction angle. To get a little bit of work here, let's at least make a basic sketch of the vector v. Nothing too fancy. Here's my coordinate axes. This is a vector who goes -4 units in the horizontal direction, and then -4 root 3 units in the vertical direction. And so we're looking at a vector v here who's pointing in quadrant 3. The direction angle theta refers to the angle it makes with the positive x-axis. So we'd be looking for an angle that's somewhere between 180 and 270 degrees, or between -90 and -120 degrees. Now for me, the easiest way to solve this problem is to first focus on just this triangle right here, and to find this angle, what's called the reference angle. So let's just sketch that triangle really quickly. It's got one side of length 4, another side of length 4 root 3, and it has a hypotenuse, courtesy of our magnitude calculation, of 8. And I would like to find this angle here, which I'll call phi, the reference angle. Notice that the opposite side of this angle is 4 root 3, the adjacent side is 4, and since opposite over adjacent is the tangent, we know that the tangent of phi is equal to 4 root 3 over 4. Or, making that cancellation, that the tangent of phi is equal to root 3. And that means that phi is a 60-degree angle. So now we know the reference angle. This angle here is 60 degrees. Since this portion of the angle contributes 180 degrees, we'd have 180 degrees plus 60 degrees for a total of a direction angle of 240 degrees. However, since this is a trig class, we never use degrees, so we can convert this into radians as 4 pi over 3. And so there would be our direction angle. However, it's also worth noting that you could count the direction angle starting from the x-axis in a counterclockwise direction. Since this is 60 degrees off of 180, this would be a -120 degree angle. And so it's just as correct to say that the direction angle is also a -120 degree angle, or -2 pi over 3 radians. Both of these are completely correct answers for the direction angle.